All right, let me start class off this way here. And you don't need to copy this down. This could be on there tomorrow, right? RST. What do I call that angle? Angle RST is called a what in the circle? That's called a what? 11, what's that called? What's it? That's the arc, minor arc, but the angle, sorry, I should have mentioned, this is the center right here. S is the center. That's A. The RT is a minor arc. RT is called a minor arc. Yep. RT going this way is a major arc. But angle RST, if the vertex is at the center, what do I call that one? 4? Come on. We got some reviewing to do tomorrow. 7. Central angle. That's called a central angle. All right, when the center is the vertex. How do I find it, by the way? Angle RST is the same as what? What's the theorem say? It's the same as 1, Anna? Central angle is the same measure as? There you go, arc RT. Do you have the same? All right, everyone good? 50 degrees, 50 degrees. Okay. I didn't want you to do that on your, I didn't want you to do that on the actual circle there, but it's okay. All right, so I'm going to show you a new type of angle today. Central angle, center's on the, vertex is on the center. Inscribed angle. Inscribed. The vertex now goes on the circle. Goes on the circle. So go ahead, put a point on your circle for me. And the two sides have to be chords. So draw me 2 chords now, coming from that point on the circle. Draw me 2 chords. They have to be chords. They just can't stop in the somewhere inside the circle. They have to be chords. And then you can label it A, B, C. That is an inscribed angle when the vertex is somewhere on the circle. We talked that the central angle is equal to its arc. Not this case. They're not equal anymore. They're not equal. Here it is. Ready? Inscribed equal. Inscribed angle. Ready? Half its arc measure. Half. Not equal to the arc. Half its arc measure. So go back to my inscribed angle. Angle ABC is equal to half of arc AC. That's how I find an inscribed angle. Half its arc. All right. So see the difference between inscribed versus central. Central, the vertex is on the center. Inscribed, it's somewhere on the circle. All good? All right, let's do some examples. Get your calcs ready. Here we go. We labeled arc AC as 88, angle A is 80. Let's find arc BC. How about the measure of arc BC? Angle A is what type of angle? You only have 2 so far. You have central and you have inscribed. What type of angle is angle A? 9? That's inscribed. So I know it's equal to half whatever its arc was. So if the angle's 80, how do I find its arc? Remember, the angle is equal to whatever half its arc was. So I'm kind of going backwards here. So what can I do with that 80 to find the arc across? 12?
BC divided by 2 equals.
Yep. So what do I end up doing the 80 then?
Multiplying
Not dividing it by 2, but multiplying it by 2, because the angle is half whatever the arc is. So I'm going to multiply by 2, and that's going to be 160 degrees. Everyone see that? The inscribed angle is equal to half its arc. So let's label that 160 now. All right, how about angle B now? Angle B, what type of angle is angle B? Central or inscribed? 8, central or inscribed?
Inscribed.
So I know it's going to be half its arc. So everyone look at its arc that it's drawn to. What's the arc measure for angle B? 3? 88. So take a look. I'm going to take half of 88. And that's 44. It's equal to half 44. Label it on your diagram. It may help later on. You never know. All right, how about angle C now? There's a bunch of ways you could get to angle C. You don't need to even use any circle facts, right? If you don't want multiple ways to get to angle C. Some of which have nothing to do with circles. All right, just talk to me. How are you getting to angle C? 9, how are you getting to angle C?
185 over 2.
Yeah, that's fine. I don't have to do anything with circles, right? 180 minus 80 minus 44. And that gives me what? There, 56. All right, so that's 56, angle C. And then how about AB, arc AB? How you going to lead me to get to arc AB? 6. Now here. Thanks, guys. 2.
It's across from angle C.
Yep.
So you just double.
Okay.
Angle C.
I could double 56. Did anybody subtract the other 2 arcs from 360? Because you could do that too. That's fine too. Yep. Double 56 or subtract from 360, and that gives me 112. All right. All right, no issues? All right. Here we go. I'll let you guys try this one out on your own. Find angle ADB and angle ACB, and then we got to talk. They're both inscribed. Angle ADB and ACB are both inscribed. So they should be half its arc. What'd you find out about the 2 angles? 7, what'd you find out?
They're both 62 degrees.
They're both equal, right? And they're both equal to what again?
62.
62 degrees. Everyone sees that? 62. Why are they both 62? Because they're both drawn to 124. So here comes your new second theorem. First theorem we learned was central angles equal to its arc measure. Here's the next one. 2 inscribed angles and I'm going to have you guys help me finish this. 2 inscribed angles. Where are they drawn to? Where are these 2 drawn to? Those 2 inscribed angles we just found, they were drawn to where? 13? Thank you. Drawn 2 inscribed angles, drawn to the same arc. So if I have 2 inscribed angles drawn to the same arc, they are, what'd you find out about them when you did the algebra? Thank you. They are congruent. So if I ever see 2 inscribed angles drawn to the same arc, I know they're going to be congruent. All right, go ahead. Example 3. 6x plus 26. ACD 13x minus 9. Find arc AD. Find the arc AD. All right, a couple questions for you. One, Anna, what type of angles are those? Central or inscribed?
Inscribed
Inscribed, and they're both drawn where?
to the same arc,
Yep, which is what? Name it.
AD.
Everyone see they're both drawn to AD. So that must mean, based on the theorem we have, Anna, they are? Yep. So I'm going to take 6x plus 26, set it equal to 13x minus 9. I'll let you guys solve for x, and we'll talk how do I find the answer now. And what do you have for x when you're ready here? 11, x?
5.
5, good. All right, that's x. We're looking for AD. How do I use that 5 to find the measure of arc AD now? How many degrees are in arc AD? How can I use that 5? Little talk here. 4. What do you got for me? How can I use that 5 to find the measure of arc AD?
You should just be able to plug it in for one of the angles.
Okay, plug it in for one of the angles. And all right, so let's do that first. You're not off the hook yet. So let's plug it in, guys. I'm going to plug it into 13x minus 9. 13 times 5 minus 9. That angle is 56. All right, how do I get the arc now? What type of angle did you just is 56?
The inscribed angle.
Okay. And an inscribed angle, how do you always find it? It's equal to?
1/2 of the arc.
Good. So if the angle's 56, how do I go in reverse there to find the arc?
Multiplying it
By?
2.
There you go. So I'm going to take 56, multiply it by 2. 112. Any questions? We sure? All right. It's a big day here, huh? All right, ready to find x and y with me? Let's start with x. What type of angle is x? Remember, it's only central or inscribed. Those are the only two you guys know so far. 13, central or inscribed? Inscribed. So it should be, ready? X should be equal to half of some arc, right? Because that's how I find an inscribed angle. I take half the arc. All right, let's see. Anybody see where it's drawn to right here? The arc that it's drawn to, if I just highlight angle x. Everyone see that arc? What do I call that arc? We have gone over this, and it'll be on the quiz tomorrow. What's that arc called? What type of arc is that? 12? A to B? And remember, this is what. First of all, what's AB? That's a what? Okay, so this would be A. Come on, dig deep. Do you know what it measures? Okay, 180. Yep. Not going to let you off the hook. What's an arc called that measures 180? Not minor, not major. Doesn't even have the word arc in it. Semicircle. All right, that's a semicircle. Everyone agree? All right, and it's 180. So everyone, all right, that I'm taking half of 180. And why? So it ends up being a right angle, 90 degrees. And before we find y, that's what this theorem is that's written in for you says. If you have a inscribed angle drawn to a semicircle, it forms a right angle. All right, because we're going to use that in the proof here next week. I know you're excited to hear that. All right, so again, inscribed angle drawn to a semicircle, always right angle. Inscribed angle drawn to a semicircle. All right, go ahead and find y now, however you want. I think there's only really one way to find y here. How you finding y? Oh, 10? New one.
Do 26 times 2.
Ooh. Is this inside the circle? So it's not inscribed. This has to be on the circle. So that 26 is really just there to mess with you, and it did. All right. Inscribed angle iris, it's got to be inside the circle. So another way to find y without even doing any circle facts.
Oh, 58 plus 9.
And then subtract it from.
180.
There you go. Yep. Everyone good? I threw the 26 out there just for you to look at it, but it has nothing to do with anything. It's outside the circle. Nothing we know right now, anyway. And what's that end up being? 32, everyone? All right, last fact. So I just threw at you that if you have an inscribed angle and you draw it to a semicircle, it's automatic right angle. Next one, here's what I want. Draw a circle down below this last theorem here. If a quadrilateral is inscribed in a circle. So draw a circle there for me. You're going to do your own diagram here. And I want quadrilateral, how many sides? 4 sides, right? And if it's inscribed, that means every point, every vertex is touching the circle. So just draw a random quadrilateral inside your square, but the vertices have to touch the circle. Come on, Spence, let's go. I don't care what it looks like. It just has to be 4 sides and the vertices have to touch the circle. And name those points that it touches. All right, name the points where the quadrilateral touches your circle. All right, hey, you have this? Quadrilateral inside a circle. Opposite angles are supplementary, meaning they add to 9, 180. So in my diagram, angle A plus angle C equal 180. Angle B and angle D add up to 180. All right, if you have a quadrilateral inside a circle, the opposite angles add to 180. And that's how we're going to finish it. Let's try this out. Everyone see the quadrilateral inscribed there? Find GFE. So take a look. Follow the order of the letters G to F to E. How many degrees are in there? Don't overthink this. Who's up here? 9. What type of angle is 86? Inscribed. How did I find it? How's an inscribed? How do you find any inscribed angle? This is what we wrote down first thing today. How do I find an inscribed angle is equal to? Very beginning. Inscribed angle is equal to? Half its arc. Now I want you to tell me 86 degrees is drawn to what arc? The one I'm trying to find. So how do I, if I know the inscribed angle, how can I find the arc? By? All right, that's all I'm doing here. Taking 86 and multiplying it by 2. (172 degrees). And then how do I find angle F? I use the theorem we just provided, which is what? Quadrilateral inside a circle, the opposite angles are supplementary. So how can I find angle F? Finish it off. 6. Good talk. 10.
It's the 86.
What's that?
For F,
For F. Yep. How do I find angle F?
it's the same, it's supplementary.
So not congruent, supplementary, right? Yep. So I'm going to take 180 minus 86. And we end up with, what do we have there? 94. Check my math there, anybody? 94 degrees, because they're supplementary. This homework's due on Friday. So right now we got plenty of time. Let's get out the Chromebooks. Let's get on Delta Math. Have a spare sheet of paper next to you to write some notes down if you need to, or work, some calculations. And let's start reviewing for tomorrow's quiz. Days 1 through 4. No inscribed angles on there tomorrow.